What's up, eighth graders? Welcome to another class. Today is class 112, okay? And today's topic is trigonometric ratios, okay? Now, before we talk about what these mean, let me say this. This topic is like so useful I've used it in 9th, 10th, and 11th grade this year in geometry, 10th grade physics, and 11th grade physics. Engineers need to understand trigonometry because you can use trigonometry to find out unknown sides or angles of right triangles. So this is the introduction to trigonometry, and I'm really happy that we get to do this year because sometimes in 8th grade, there's not enough time at the end of the year to talk about trigonometry. But the fact that we are able to talk about the trigonometry basics this year is going to be really special for you, I think, because it's going to help you learn in 9th, 10th, and 11th grade even easier when it comes to geometry and physics, if not even more classes. So here we go. Let's do this. There's 3 trig functions that we're going to talk about today. And you've actually seen these buttons on your calculator before. The first one is what we call sine. The second one is cosine. And the third one is tangent. And you can actually see each of these represented on your calculator. Let's go like this. Boom. Sweet. You can see these, you can see the sine, cosine, and tangent buttons on your calculator right there. And so for today's lesson, you don't need to use your calculator, actually. We're just going to be talking about the basics, which don't require your calculator yet. Okay? So let's talk about this. I'm going to make this a little bit more transparent. Cool. So there's an acronym that we use to remember the basics of the trigonometric ratios. So here's the acronym. The acronym is SOHCAHTOA. SOHCAHTOA. So that is SOH, okay, and then TO, bah. This is my 3rd time recording this video. So, Toa. Okay. Now, if you say it fast, SOHCAHTOA, it sounds like the name of an indigenous woman, like Pocahontas, SOHCAHTOA, whatever. Now, let me tell you what each of these actually represent. Okay. Now, when we say SOH, what we're saying is sine of what we say theta. Sine of theta is equal to opposite over hypotenuse. COOHH. Opposite over hypotenuse. Okay. Theta is a Greek letter. Greek letter theta.
According to Wikipedia, theta is the 8th.
Okay. And this symbol represents an angle. I'll say it again. That symbol, theta, represents an angle. Okay. Now let's talk about Ka. CAH represents cosine of theta is equal to A adjacent over hypotenuse. Once again, this symbol, theta, represents an angle. And I'll tell you in a minute what the opposite hypotenuse, adjacent hypotenuse represent, okay? And last one, we have TOA. This represents tangent of theta is equal to opposite over adjacent. Okay, so there's our three trig functions. If you compress like all of that, then you just have SOHCAHTOA. And this is basically the way that I've always used to remember the three trig functions, sine, cosine, tangent, right? SOH, SOH, CAH, CAH, TOA, TOA. Okay. Now, like I said, the theta, theta, and theta represent an angle and a triangle. Okay. And the opposite hypotenuse, adjacent hypotenuse, and opposite adjacent, those all represent sides of a triangle. Specifically, sides of a right triangle. Okay, these only work in this topic if they're right triangles. Okay, if you have a triangle that has like three angles and none of them are 90 degrees, then you cannot use SOHCAHTOA to solve for unknown sides or angles. But you can see we have a right angle here that is 90 degrees, is right. And then right angle here, again, 90 degrees. And then this one, we have a 90-degree angle right there. That little square, right, that means 90 degrees. Okay, so now let's talk about how to identify which side is opposite, which side is hypotenuse, and which side is adjacent, okay? And when you see this line, opposite over hypotenuse, that is division. Division, division, okay? So for this first triangle, we're going to use angle A as the reference angle, okay? And it's very important that we remember that A is the reference angle. And then for the second example, we're going to say that C is the reference angle, okay? You can forget about the triangle on the right for a minute because we're going to start with the one on the left, okay? Now let's name the sides so then we can identify them easier, okay? We're going to name this side right here, the one that is opposite the angle A, we're going to call that little a. And then typically these sides will have actual numbers, actual lengths, like you'll see in the third example today. And like you'll see on your homework, all the triangles that we deal with have actual lengths, but we're going to call the sides right now letters so we can kind of talk about the theory a little bit more. Okay, so A, and then the side that's opposite angle B, we're going to call B, little b. And then the side that's opposite angle C, we're going to call little c. Okay? Now, let's find what is the sine of A, and then let's find what is the sine, let's find what is the sine of A, what is the cosine of A, and what is the tangent of A. Okay? So we're going to go sine of A equals something. We're going to say cosine of A equals something. We'll find out. And then tangent of A equals something. Okay? So when I say sine of A, I'm saying what is the ratio of, well, where's sine up here? Sine is right here. We want to know what is the ratio of the opposite divided by the hypotenuse. Okay, so in order to do that, you need to know what is the opposite and what is hypotenuse. Let's start with hypotenuse. Okay, you can see hypotenuse, hypotenuse. Hypotenuse refers to a side, and it's specifically the side that does not touch the right angle. Here is one right angle. Here's another right angle, right? So in this case, in this triangle, which side does not touch the right angle? There's only one. Boom, little b, right? Because you can see this side, little c, touches the right angle here. And this side, little a, touches the right angle. So we know the hypotenuse is b, okay? Now let's talk about what is the meaning of opposite. Opposite is the side that does not touch the reference angle. Reference angle here is A, we decided, and reference angle here is C, we decided. So what is the only side that does not touch this reference angle, A? Well, we know that little c is touching this angle, right? And little b, the hypotenuse, is touching this angle. So the only side that is not touching angle A is the little side A. Okay, so typically little a, little b, and little c, like I said, will be actual numbers. But for right now, we're going to call them letters. So sine of this angle A is the opposite. We just said the opposite of this angle is little a, the side, right? Because it does not touch the angle A. So it's opposite A over hypotenuse. We already decided that hypotenuse is always the side that does not touch the right angle. Okay, so the hypotenuse in this triangle is little b. Okay, now cosine. Don't get confused because this a right here is not saying adjacent. It's not saying that. This a is just saying this side. Okay, now cosine. Same reference angle A, but cosine is adjacent over hypotenuse. So what does adjacent mean? Adjacent is the side that is touching the reference angle that is not the hypotenuse. Okay, once again, the side that's touching the reference angle that's not the hypotenuse. Here's the reference angle. There's two sides touching this angle. We have the adjacent side right here is actually C, little c, and then the hypotenuse is B. These two sides, the little b and little c, form angle A. Okay, so the adjacent is little c because it's touching our reference angle A, and it's not the hypotenuse, right? Because there's the hypotenuse. Okay, so cosine of A is adjacent, in this case, little c, divided by adjacent divided by hypotenuse. Hypotenuse we know is little b. Okay, so we have opposite over hypotenuse is sine, adjacent over hypotenuse is cosine, and then tangent is opposite over adjacent. Well, from our reference angle, what is opposite this? Well, it's the side that's not touching the angle, A. And which side is adjacent to this angle? C, A over C. Let me make sure we're still recording. Yes. Now, if this feels confusing with the letters, don't worry too much because once we start with actual numbers, like in the third example here, you'll see that this is like not too difficult, okay? So the numbers makes it feel kind of weird, but we're almost finished with the letters make it feel kind of weird, but we're almost finished with the letters part, okay? So now we just found out what is the sine, cosine, and tangent of A, of angle A. Now we're going to change the reference angle, okay? Because sometimes they ask you for the sine, cosine, or tangent of this angle, and sometimes they ask you for the sine, cosine, or tangent of the other angle. So now we're going to do the same thing, but with a different reference angle. Okay, so now we're going to call this this side again little c, just so we can have a name for it. We're going to call this side over here little a, this is opposite A, and then we're going to call this side little b. Okay, just like we did over here. So now let's find the, now we're going to find the sine of C, cosine of C, and the tangent of C. Okay, now I'm going to tell you something right now. When the angle changes, like we just changed from A to C, the opposite and adjacent sides change, but the hypotenuse is still the same because the hypotenuse is still opposite the right angle. The right angle is right there, is right here, and opposite that is B, okay? So sine is opposite over hypotenuse. Now in this case, what is opposite C? What is not touching this angle? Well, this little a is touching angle C, and this side, little b, the hypotenuse, is touching the angle C. So the only side that's not touching C is little c. Okay, so the sine is opposite, so little c, over hypotenuse. Hypotenuse is still little b. See that? Because the angle changed to C, the opposite, right, is now this side, right? Opposite C, opposite angle C. Now let's find the cosine of C. Cosine is adjacent over hypotenuse, okay? What is the adjacent side to C? Well, we know it's the side that's touching angle C. So which side is touching angle C? Well, little b and little a are touching C, but we know which is already the hypotenuse, B. So if B is the hypotenuse, we know it's not the adjacent. So the adjacent is little a. A over hypotenuse, we know, is B, little b. Now, last one, tangent of C. Tangent is opposite over adjacent. Okay, so here's C. Opposite C is the side that's not touching the angle C, so little c. Opposite over adjacent, we just talked about. We know that here's angle C. The hypotenuse is right here, so that means the adjacent is the side that's touching it that's not the hypotenuse, so little a. Right? So before we do the actual example with numbers, let's review this really fast. Here we found the sine, cosine, and tangent of A. Sine is opposite over hypotenuse, A over B, right? Opposite over hypotenuse. Cosine is adjacent over hypotenuse, C over B. And the tangent is opposite over adjacent, A over C. Boom. Now we changed the reference angle, and we put the reference angle here. And we said, okay, what is the sine of this angle? Not A, this time we're using C. Well, sine is opposite over hypotenuse, so opposite is little c, boom, over hypotenuse is B, C over B. Then we said, what is the cosine of this angle? Well, adjacent, we know it's adjacent over hypotenuse. When this is the reference angle, the adjacent side is little a, and the hypotenuse is little b, A over B, boom. Now tangent is opposite over adjacent. Let me go like this. So you guys know that those are separate. So here's the reference angle, C. Opposite C is little c. So it's going to be, the opposite side is little c, boom. And then the adjacent, we already talked about, is little a, boom. Okay, now if this feels weird, I understand. It's going to feel less weird when we use actual numbers. So let's do an example that's going to be kind of like your homework. Here we have a triangle. Here is the opposite. Here is the hypotenuse is 50 because it's not touching the right angle, right? And we don't know the reference angle yet, so we don't know what is the opposite and what is the adjacent side. Let me write SOHCAHTOA again here so we can refer to it. Cool. Now, on your homework, they're going to give you, example, this is your homework. You'll see that they give you something like, find the tangent of z, right? So then tangent of z, so tangent we know is opposite over hypotenuse, right? Opposite over adjacent, sorry. Opposite adjacent. So in this example here, when they say find the tangent of z, they're saying find the opposite 21 divided by the adjacent. 21 over 28. Simplified, you could do, might as well do number one for you, and then we'll do that example with 30, 40, 50. So tangent of z, we know from what I just taught you, is they're saying opposite over adjacent. So from z, they said z is the reference angle. So opposite is 21. So 21. And then adjacent, we know the hypotenuse is opposite the right angle. So this 35 is not the adjacent. The adjacent is the side that's touching the reference angle, z, that is not the hypotenuse, so 28. Okay? And they said, well, I actually didn't tell you to simplify, but you should know by now that this, if you can simplify, then you do want to simplify for your answer. So is there anything that we could divide 21 and 28 by? Think about it. Divide by 7, divide by 7. 21 divided by 7 is 3. 28 divided by 7 is 4, right? So we just found opposite and adjacent, divided them, and then simplified. And you can see the answer to number 1 is 3 over 4. Okay, so that's what your homework will look like. But let's do this example. And we're going to say the reference angle here, we're going to use C as the reference angle. So the instructions here will be find the, and then we'll do like 3 examples in one right here. We're going to say sine of C, cosine of C, and tangent of C. Okay. Well, we know that sine, like we talked about, is opposite divided by hypotenuse, SOH. So here's the reference angle they gave us is C. So what is opposite? Which side is opposite C? Boom, 40. Right? There's the O, opposite. Now, the second part of sine is hypotenuse. What is the hypotenuse? Well, the hypotenuse is always the side that is not touching the right angle, the 90-degree angle. There's a 90-degree angle. Boom, 50. Now we want to simplify. 40 divided by 50, we could divide both of these numbers by 10. 40 divided by 10 is 4. 50 divided by 10 is 5. And that is the answer to this for the sine of C. The sine of C is 4 over 5. Okay. All right, cosine of C. Here's C. Cosine, we know, is adjacent divided by hypotenuse, right? AH. So what is the adjacent to C? Well, we know the 50 is not the adjacent because that's the hypotenuse, right? It's opposite the right angle. So the adjacent is the side that's touching C, once again, that is not the hypotenuse. So it's 30. And then the hypotenuse, H, is the same as in the first part of this. Again, it's 50. Now, if we can simplify, we want to simplify. 30 divided by 50 can be simplified to divide by 10, divide by 10. 30 divided by 10 is 3. 50 divided by 10 is 5. So the cosine of C right here is adjacent over hypotenuse, 3 over 5. 30 over 50 equals 3 over 5. All right, tangent. And then we're basically, we're almost finished. Tangent, we know, is opposite over adjacent, right? OA. So what side is opposite C? Well, we already found that with sine, right? Because we already did the O there. So we know the opposite is the 40. So tangent is opposite, so 40. Boom. And then divided by adjacent is, we already talked about right here, we found the adjacent with cosine, right? There's an A. So we know we already talked about the adjacent to the side that is adjacent to C, angle C, is this side, 30. Okay, so 40 divided by 30 cannot be simplified. Yes, it can. Divide by 10, divide by 10. 40 divided by 10 is 4. 30 divided by 10 is 3. Okay, and there's those three answers depending on if you want to find sine, cosine, or tangent. Okay, let's take one more glance at your homework, and then you guys will be ready. So your homework has 8 questions. I already did the first one for you. Let's look at number 2. We're not going to do the whole thing, but we'll look at it. They say find the cosine of C. So they're saying the reference angle is C, and they want to know the cosine. Know that cosine is adjacent divided by hypotenuse. So if C is the reference angle, which side is adjacent to C? 16. Which side is the hypotenuse? It's the side that is opposite or not touching the right angle. Boom, 34. So cosine of C would be adjacent divided by hypotenuse. Okay. So everything else that you see here is doable now because you guys have already done basically problems like these in these notes here. What else do I need to tell you? Yeah, guys, that's the introduction to trigonometry. The most simplified way to describe all of this is just by saying SOHCAHTOA, because this when you like divide it all out, you know that we get that, and that. And if you know those 3 trig functions, then you can find the ratios that they ask for. Okay. That's everything for class 112 lecture. Good luck on the homework. And I hope you guys have a nice rest of your day, and we will see you next class.